Leshire Maths here. Let's turn to question number 2. And remember, question number 2, the instruction is quite clear that we must show all stages of our working. And based on also the rule for pure mathematics 2 is that all the solutions must be expressed to 3 decimal place. Sorry, 3 significant figures unless otherwise. Now, let's turn to question 2, Roman 1. To Roman 1, you're told that solve for x being greater than 0 and less than or equals to 2 pi 1 plus, maybe let me highlight 1 plus sine x plus cos x equals to 0. Now in this case, what we are going to do, starting with the number part Roman 1, we are given 1 plus sine square x plus cos x equals to 0. Now, in this case, we'll apply the concept of the identity. And recall that the identity in this case, we know that it is cos squared x plus sine squared x equals to 1. So to make sine squared x as the subject, then it means what we'll have here is sine squared x will be equals to 1 minus cos squared x. So this one is what we'll purely use. Now, normally to solve questions or equations relating to trigonometry, especially that deals in identity, we make sure that we reduce the equation to a single trigonometric ratio. That is, in place of sine square x, we can replace by 1 minus cos square x. So this one gives us, when we substitute this, we'll have 1 plus 1 minus cos squared x plus cos x, and this one equals to 0. Simplifying further, 1 plus y1, we know it is 2, so we will have 2 minus cos squared x plus cos x equals to 0. Now we can take everything on the other equal side so that we get rid of the negative as the coefficient of cos squared x. Now when we transfer everything to the other side of the equal sign, we'll have cos squared x, of course positive changes to negative, minus cos x, then plus 2 equals to 0. So already we have a quadratic equation involving trigonometry. So solving this, of course, we can use product sum rule. We'll have cos x minus 2, and of course multiply this one by cos x plus 1, and this one should be equals to 0. So in either way, we'll have cos of x minus 2 equals to 0, or we can also have cos of x plus 1 equals to 0. So if we solve the first one, then it means this one implies that we'll have cos of x equals to positive 2. We can ignore this. So for the first one, we can ignore this because it cannot be solved. Ignore. But then we pick the second. cos of x plus 1 equals to 0. Taking 1 the other side, we'll have cos of x equals to negative 1. Now, going back to, we can get the value of x. So x will be equals to the cos inverse of negative 1, which is simply equals to 180 degrees. Of course, if you try this with the calculator just to confirm, we'll have the cos inverse of negative 1 gives you 180 degrees. Now, going by this, based on what we have from the unit circle, from your unit circle, this means that if this is 0, this is 180, and of course we know this is 90, this is 270. So alternatively, in terms of pi, we can say that x is simply equals to pi. So this one is the solution for Roman 1. We can go ahead and answer Roman 2. Can go ahead and answer Roman 2. The question is up here. So Roman 2, you are told to solve for the range theta is greater than 0 but less than 180. Sine of x plus 60 equals to, so this one is sine of x plus 60 equals to, what are we given? We are given 4 cos of theta plus 60. Now, what we can do, we can, the first step we can have is this. We can divide through by cos of theta plus 60, and also on this side by cos of theta plus 60. Remember, we are using theta, so this one prompts me to change the first part. Now, simplifying this two, what we remain with is simply sine of theta plus 60 over cos of theta plus 60 equals to 4. But remember, I want you to recall something that remember that tan of theta is just the same as sine theta over cos theta. So this implies that if at all we replace this, then it implies that the ratio of sine theta plus 60 to cos theta plus 60, we can replace this one with the, so we can say that sine theta plus 60 over cos theta plus 60 is simply equals to tan of theta plus 60. So therefore it means, what it means is that tan of theta plus 60 is simply equals to 4. What do we need to do? We can get the arctan or the tan inverse so that we get the corresponding working angle. So we can get, so we'll have here theta plus 60 should be equals to the arctan of 4. So let's test and see what the working angle in this case is. So we'll have theta plus 60 should be equals to, simplifying using a calculator, we can get the arctan of 4. The arctan of 4 gives you, it gives you from our calculator 75.96. So this one is 75.96. So what do we need to do here? So theta in this case will be equals to 75.96 minus 60, and therefore theta is equals to the difference. Let's see, this one minus 60, it gives you 15.96 degrees. And remember, expressing this solution to three significant figures, then it means our theta in this case will be equals to 16.0 degrees, and this one becomes your solution.